All right. Good evening, everybody. I hope everybody had a good week. It's kind of a long week, but I figured what I'd do is I'd hop in today and kind of show you. There were a couple things from last time that we never really got settled. One was the service areas, and the other one that came up was a question that I had given to me was, hey, sometimes that geocoding service doesn't work. What are my options to do then? So I'll show you those two tonight. I'm not going to do something crazy long tonight, but I figured cover service areas. There's a cool plugin that you can use that would get most of everything that you need to do to generate service areas free, and then I'll show you a quick way to convert lat long into features that you then use in your map. So to kick it off, the service areas. So remember, in our project, we have decided that our home base is going to be this location here in Illinois. Just happens to be the famous house from Groundhog Day. But one of the things that we're going to do is we're going to generate these drive time service areas. Now remember from last week last time we chatted, we could do buffers. And again, buffers are really easy to calculate. Just make sure you're in the correct projection. You're in a generally you want to use a UTM zone. For the projects that we're working on, we're going to want to choose the UTM zone that our project is within, our area of interest is in. So for here, I believe we chose the projection, zones, UTM zone 16. You can see that I've got our OpenStreetMap base map up, but I am using a Web Mercator projection right now. I'm going to go ahead and convert that to our UTM zone projection. I'm going to choose this one. It's going to say, hey, it's going to use some ballpark transformations. That's okay. And remember, when we create a buffer, we just go to Vector, Process, Geoprocessing Tools, Vector Buffer. We choose our distance. Let's do 1 kilometer. So we can either do 1,000 meters or we can do 1 kilometer. We just change the setting. 10, we'll make it a little nice and round. And we'll just save it to temporary scratch space and click run. We'll click close. And there is our 1 kilometer circular buffer around our home base. If we want to change our style again, just double click symbology, pick one, doesn't matter. We'll get into advanced styling a little bit later. And then that's 1 kilometer around this base, home station, whatever you want to call it. But that's as the crow flies. What if we wanted to do a drive time analysis or drive distance analysis buffer, where we said, hey, let's use the road network to give me 1 kilometer. How far can I travel on the roads 1 kilometer? So there's this plugin. We'll go in the plugins here. There's this plugin that I found, which is really good. It's a really good plugin. Keep moving my windows here. Called ORS Tools. It's Open Route Service Routing, Isochrones, and matrix calculations for QGIS. So isochrones are what we're actually creating. Service areas are isochrones. I'm not going to get into nitty-gritty details about what they are. Just know that they are buffers that use a network, in our case roads, to create a distance polygon. This plugin, so this is the openrouteservice.org. It is a free service that you essentially sign up for. You get an API key, and then you use that API key to create these Isochrones service areas or routing network drive times and directions if you go from point A to point B. There's also a couple other really cool, neat things, like if you have multiple stops on a route and you want to deliver those, whatever it is, goods in the most efficient way, you put all your points on the map and it will calculate the proper route for you to go. So, highly recommend it. It's a great tool. There are some limitations with the open source implementation of it. If you want to get rid of those, they have some instructions where you create your own server service that you can host yourself and utilize, and you have no limitations. But for what we're going to do, the free plugin is fine. The free API key is good. We can just move on. All right. So once you install the plugin, you are presented with this ORS Tools button. So I'm going to click on this. And this is going to be driving directions. And we can then say, hey, if I want to go from point A to point B, avoid, this is that traveling salesman. So like, how do I, round trip, fixed start, how do I deliver or sell if I need to visit a bunch of spots at the same time? That's the traveling salesman, because you need to also go back home in theory. So that's that type of calculation. Avoid tags, avoid countries, avoid polygons. So if you were if you wanted to do this dynamically, where you're pulling in a service like road closures or flooding or bridges, you could use this avoid polygons or avoid tags in the network to prevent you from doing something. For those that drive big trucks, there's limitations on certain types of roads that you can go, certain types of bridges that you might not be able to drive over or under. If your road network in your GIS is set up to have those features, you can leverage those too. But what we're going to do is go over into ORS tools in our processing toolbox. So that processing toolbox is under processing toolbox. It pops this, processing toolbox window. Go to Isochrones. Isochrones we'll do from layer since we have a layer here already. Double click that. Our input point layer is going to be home 3. Input field ID. Don't need to do that. How are we traveling? We'll just choose car. We'll do distance, and we'll say 1,000 meters. Click run and close. So here you go. This is a isochrone, a service area roughly generated. Again, if you use the open source tools, they generalize the features a bit, but this gives you a good enough idea. But it's 1 kilometer as you drive versus 1 kilometer as the crow flies. So you can see that there is a difference. So why is there a difference? Well, let's take a look. So I'll just change this to green here. Okay. That's not as good. Let's do a little bit of fill here. Simple line. We'll do simple fill. We'll change this to green also. Effects. Yeah, we'll do that. Okay. So we've got that. Okay. So you've got this red circle that's 1 kilometer as the crow flies from this. What's really cool is if you look at this isochrone, as you drive, you're eating up part of that 1 kilometer distance. So if we were to drive straight up South Madison Street, you can see it's straight. We just go straight all the way through, and we can go straight all the way up. No stopping, no deviations, no turning, whatever. We can go essentially right to our endpoint, 1 kilometer. But you see, if we go south, we can't go straight. We are limited by turns, and we're limited by the roads. So 1 kilometer in travel distance as the road drives, you know, if we come down here and we go on Lawndale Avenue, onto Roosevelt Road, onto Oakwood, onto South Jefferson, down to Burbank, that's eating up part of that distance. So traveling 1 kilometer is not the same as flying 1 kilometer. And this is a perfect example that shows you that. Now, what's really cool is you can use both in your analysis when you start to figure out, hey, I want to know what's around me, or what can I get to in either drive time, so we have distance and time, and time takes into account speed. And so if your road network has speed in it, like speed thresholds, like speed limits, then that would change how far you can get if you obey the speed limit, obviously. How far you can get in a given amount of time. But just doing distances, this I wanted to show you, can be a little bit more accurate for the type of analysis that you're looking to do. So if we scale this up, so let's do another one. And instead of 1 kilometer, choose the same thing. And we'll do distance. Let's do 2 rings. We'll do 5 kilometers, and then we'll do 10 kilometers. I'll click run. And you can see it's actually really quick. So we'll close. So here you go. Here are 10 kilometers, this outside ring, and then 5 kilometers, this inside ring. So this is how far you can get. And well, where you can go at 5 and 10 kilometers. Now you can start to do some pretty cool analysis that's saying, okay, what is inside of these polygons? If somebody lives out here, how can they get to me? Or if I live here, where can I go? So in 10 kilometers, you know that you can get to Heartland Airport. Heartland Hunter Airport. Now we just used the road network. We didn't use the railroad. Because if we use a railroad, clearly we could probably get a little bit further. So those are service areas and drive times, also known as isochrones. The next thing I wanted to show you was how do you bring in a list of latitude and longitudes into QGIS that you can use. So let's do one thing here. Let's go and let's go to, all right, so we're in Woodstock, Illinois. So I'm going to pull up a browser window here. Just give me a moment. All right, let's go over to Woodstock, Illinois. So we got one window here. I'm also going to simultaneously pull up a notepad. Give me a moment. It's just in another window. All right. Bring this over here. All right. So we got two windows. So what we're going to do is name. So this is a new document. Text document. It's going to be a CSV file. So we're going to create our headers. So we're going to go name. We'll do latitude and longitude. That's all we got to do. All right. So let's go and let's create some points of interest here. All right. So let's go to all right. Oh, Taco Bell. Why don't we pull the Taco Bell? Okay, so in Google Maps, what you can do is you can actually click on a feature and pull up that information, obviously. But what you can also do, which I found really awesome and super handy, is being able to right-click. And as soon as you right-click in the browser, now I'm in Chrome, Firefox actually. As soon as you right-click, you're prompted with all this information. I generally just like to do the copy the coordinates. So those coordinates are copied to clipboard. And so over here, what we can do is we can call this Taco Bell, comma, and then we just paste those coordinates in. All right. We'll do the next one. What's another one? Let's do, let's go. All right, Woodstock lumber. Oh, actually, you know, let's go to the Walmart. Walmarts. We definitely need to have Walmart in our map. All right, so we've got the Walmart. Clicked on it. 3.9 reviews. That's awesome. All right, click that again, and then we'll type in the Walmart. Ooh, it's a Walmart Supercenter. Walmart Supercenter, comma, and then we'll paste those coordinates. What I'm going to do is I'm going to get rid of these spaces. They should be okay, but CSVs generally are pretty particular about formatting. All right, let's do one more. Let's go up here in the north. Let's see what's here. Whoa, Rosie's gluten-free sweets. And we'll take care. And we'll put this as Rosie's. And we'll paste that. Get rid of that space. Get rid of this space. All right. And what we're going to do is we're going to save this. We'll save this as points, POIs, points of interest, .csv, and we're going to, should just be able to do that. It should just save it. Awesome. So points of interest are saved. Close this. I'll close this and go back to QGIS. And then we will open that file. So then we go into Data Source Manager, and we choose delimited text, and we will browse to that project. Point CSV, and we will open that. And you can see QGIS automatically knows what to do with it. So we've got a common delimited file. That's great. Geometry definition, we automatically loaded lat long because we did it properly. Remember, longitude is your x-axis, latitude is your y-axis. Automatically pulled in the coordinates. Geometry. For whatever reason, it didn't know what to pull it in as. If you're using latitude and longitude, make sure that you choose EPSGID 4326, WIGS 84, WGS 84. It's decimal degrees, so you don't have to worry about anything else. And we'll click Add and close. And there are our points of interest. There's our three. So here's Rosie's, the Walmart, and Taco Bell. And so we've added those. Now they've been added to the map. They're still sitting as a CSV. They're actually not they're not in like as a GIS based file. If you had a lot of points, there's a variety of things you can do. You could do that every single time you open up a project, but it kind of gets old. So what I would recommend is save, once you've loaded these in, save these features as, if you have a lot of points, I recommend saving them as a spatial light database file. If you don't, the other file that I like to use, I think I brought this up in the past, is a GeoJSON file. So we'll just call this points of interest, POIs. Actually, you need to save it as a particular location. So we'll do that. POIs. It'll save it as GeoJSON. Save. Automatically done. Good. There we go. Delete the old CSV layer out of the project. And there we go. We can change these as points of interest. Make them big red stars. And there we go. And there are our points. If we want to label them, let's go into right-click the layer, go into Show Labels, and then we've got Rosie Sweets, Taco Bell, and the Super Walmart. There's a way where you can change the style of our labels. I'll probably have to get into that a bit later. I don't do that a lot. I usually don't make maps for publication. I make maps for analysis, and I usually just export pictures of things. But all you have to do is essentially right-click, go into the layer, go into the labels section of the layer, and we can change the size here. So if we want to change this to, let's say, 14, and change our font to, I think I have Special Elite in here, Google font. I love that font. Hit apply. Okay, there we go. Now we got Rosie Sweets, Taco Bell, and the Walmart Supercenter added to our map. And they are all inside our isochrone. So they're within our, Taco Bell is actually within our 1 kilometer as the eagle flies buffer. So that's pretty much it, everybody. I wanted to do it really quick, kind of just cover those two topics, and let you guys be on your way. We're gonna, as I said before, progress into something more advanced as we go through. We'll probably use these isochrones to then start doing some better analysis. Who lives and who is within our 400 kilometer walking distance. 400 kilometers, geez, that's a long walking distance. 400 meters, 5-10 kilometers. Let's start to figure out like what is within our immediate area of interest, and then that way we can start to use some intelligence and start figuring out, hey, are there certain particular things that I did not think of before that makes me vulnerable or gives me a heads up that if something happens, I need to be aware of this. So all right, everybody, I really appreciate everything that you guys do for us. We, just as a heads up, we just launched a preparedness coaching program. If you are interested in having us help you one-on-one directly with your projects, whether it be geospatial intelligence, emergency preparedness, cybersecurity, just overall general resiliency when it comes to disaster events or just being secure in your persons, it's something that we provide. So head on over to threatowl.llc and you can find some information about it. As always, I appreciate everything that you guys do for me, for the company, and stay safe out there, and I will talk to you guys soon. Thanks.